Hi everyone. Well, happy Monday. I mean, it's I know it's Monday for you. It's not Monday for me, which is why I'm wearing my Norwich City tie today as a Friday one. It has all got too confusing the way I was doing it before, and I just want to make sure that hopefully Norwich still have at least a 7-point gap at the top of the championship table by the time you're listening to me, as they do now as I'm talking to you. Anyway, before we get on with the main part of the lesson, today's starter is called a futoshiki, which is a little puzzle all hinging around inequalities, which is an essential maths skill. I'm going to show you how it works and put in one number for you now and challenge you to see if you can, before the next lesson when I will show you the final solution, see if you can work out where to put all the other numbers. It's quite tricky, but quite fun. When I say fun, you may think, really not sure that I agree with your idea of fun, and philosophers have argued over different types of fun. There are types of fun which are instantly rewarding and others that take a little longer. Anyway, here's the puzzle. So an inequality is telling you whether one number is bigger than or smaller than another. So it's like an equals sign, except that it's been pinched at one side to say that it's not equal, and more than that, the number, whatever you've got at the shorter end, the pinched end, if you like, is a smaller number than what you've got somewhere else. Now the numbers 1 to 5 are going in every row and every column, but in a mixed up order, and also wherever you get an inequality, it's got to obey that rule. So this cannot be a 1, it cannot be a 2 because we've already got a 2 in this row. So it has to be a 3, a 4 or a 5. Down here, this means that this must be a 3 or a 1. It cannot be a 2 because we've got a 2 up there. Now the number I'm going to place for you is going to be a 5, and the reason for that is, in this column I know that this number here must be smaller than 4, so it's a 3 or a 1, and this number here must be smaller than this one. Now we don't know what this number is, but the biggest number it could be is a 5, meaning this number can only be, well, it can't be a 4 because you've got a 4 there, so this number is a 3 or a 1 because we've got a 2 up there as well. So that cannot be a 5, that cannot be a 5, there has to be a 5 in each column, so I'm going to put a 5 there. And what I would like you to do is make a copy of it. If you can't, you don't have to use a a printer or whatever. If you've got some square paper, you could do what I've done there to show you exactly what I would do there, and you can set it out exactly the same. Anyway, you don't have to do it now, you don't have to do it at all, but if at some point during the day you get really bored and think, well, what shall I do? I'll have a cup of tea and just mull over a puzzle, you may find you actually sort of quite enjoy it. Here's the question I asked you to have a go and upload to me, and those of you who did had a really good go at it, and a couple of you even got 2 marks out of 3, which I was really impressed by, because I almost didn't put this up thinking it's a really difficult question, but I know you guys can really do some good stuff, so I thought I'd see if you could, and well done to you. So we've got an income of £2,000 a month. Now I'm going to draw that as one big bar saying £2,000 a month, and then I'm going to think about each time it being in a different way. So here's £2,000. When it comes to rent, it's talking about fifths, so that would be looking like that. So 1/5 would be 2,000 divided by 5, which is 400, and he's got 2/5, so there'll be 400 in each one of those, but we're just interested in those. So 2 times 400 equals £800 on rent, and then 3/20, well, that would be cutting it up into 20 parts, wouldn't it? And then to work out what one of those 20ths are, we'd have to do 2,000 divided by 20, which is actually 100. And I had a couple of you getting that but then one of you staying with only 100 and one of you ending up with 600, which is too much. You've actually got 3 20ths. So that's 1/20, 100 times that by 3 gives you 1100 there. And then on top of that, he's going to spend 1/10 on food. So 1/10 is like, well, if you look at the fifths, each tenth is going to be half of a fifth, isn't it? And 2000 divided by 10 is 200, which is the same as half of that. So we just want 1/10, so that's 1/200. So that means that the amount that he's spent, that Stan is spending, is those three numbers added up: 800, 300 and 200. Add those together, 8, 10, 1300. So then if we draw another bar just saying how much he's got 2000 altogether, and he's going to save what's left over from 1300. So 2000 take 1300, or count up from 1300, gives you £700 that he would save. Now today's work comes from this attached worksheet that you should find on class charts, ratio fraction problems. So we're bringing a bit of ratio as well, but they key in really well and work well with bars, so I thought this was a good time to have a go at some of this sort of stuff. So here's the first question. Pause the video and see what you make of that. Right, so we know that the ratio of blue sweets to red sweets is 5:3. So this is saying blue to red. Now what we do here to make this really clear is, what that means is that every part's the same, and I'm going to use little boxes to make a bar. So blue has got 1, 2, 3, 4, 5. Whereas red, we'll make this really clear by using a colour, red has got 1, 2, 3. And what it's saying is that for every 5 blue sweets you've got, you'll have 3 red ones. So if we want to know what fraction of the sweets are blue, we need to know how many there are out of how many sweets there are altogether. So that means that 5/8 of the sweets are blue. Here's a very similar question. Give this one a go. So blue sweets to red sweets, so it's still blue to red, so it's always in the order that they say it. Blue is 2 and red is 1, 2, 3, 4, 5, 6, 7. So that means the fraction of sweets that are red are the 7 sweets that you've got there out of the 9 that we've got all together. Very similar question 3. Pause the video, give it a go. Blue sweets to red again. So blue to red, 1, 2, 3, 4 blue, and 2, 3, 4, 5, 6, 7, 8, 9 that are red. So we've got that many all together, but we've got 4 that are red, and all together, sorry, blue, we've got the blues and the reds, making 13 altogether, so 4/13. Now we may have two kinds of people here, people who think this is really easy and people thinking this is really what's going on. Either way, it's going to gradually get a little more complex as we go along, but even if you're finding it confusing, keep going. look at it, pause the video, write down what you think you can do. Don't worry if it's going wrong, then watch what I do. Blue to red to green. So we've got 5 blue, we've got 3 red, and we've got 2 green. What fraction are green? Well, we've got 2 green out of 2 plus 3 makes 5, 6, 7, 8, 9, 10 all together. So 2/10. Now you may well be asked to leave it in its simplest form, in which case, because 2 goes into top and bottom, you can divide them both by 2 and that would give you 1/5. But as long as you got 2/10, that is the right answer. Question 5, pause the video, give it a go. So we've got blue sweets 2 to red sweets 4 to green sweets 5. What fraction are red? Well, first of all, how many are red? 4 are red, that's the numerator, that's what numerator means, the number of something. Out of how many have we got all together? So that's all of them. So we've got 2 there, so 4 plus 2 makes 6, and we've got another 5 there, 6 plus 5 makes 11. Last one like this before we go on to something slightly different. Pause the video, give it a go, and you should have something looking like that to start off with. What fraction are blue? Well, we know we've got 6 blue, so that is 6. We've got 4 green, 6 and 4 make 10, and then we've also got 9 red, 10 and 9 make 19, so we've got 6/19 that are blue. Question 7 is asking us to go the other way round. There are only red sweets and yellow sweets. 2/3 of the sweets are red. Write down the ratio of red sweets to yellow sweets. Well, what can we do? Well, we could start off by just drawing a bar, because in the way we made a bar before, didn't we? We've been making bars out of lots of squares. And because it says 3, that means we've got 3 all together. Only some of them are red and some of them are yellow. So 2/3 of them are red and the rest are yellow, which is just the one there, isn't it? Let's do that green. I know that's not yellow, but and so that is 1. Now to make that into a ratio, all I've got to do is stick a colon in there. So 2 to 1 is red to yellow. Give that a go for question 8 now. Red and yellow, 3/5. We know we're dealing with fifths, so we draw a bar and then say, I know this has got to be cut up into fifths. Now when I'm doing fifths, I go nearly as far as halfway and I cut that smaller one into 2, and then the larger bit I cut into 3. Like that. That works for me. Right, 3/5 are red, so that means that one, and that one. So that gives me 3 that are red, and the rest are yellow. So that gives me the 2 that are left over. So that means that my ratio is just there as 3 to 2.
Last one like this. Question 9. Only blue sweets and green sweets in a bag. 5/6 are green. Write down the ratio of blue to green. Go for it. So it's 6ths this time. Not too difficult to split a bar into 6. Cut it into half. Then each of the halves needs to be 3. So then if I turn that into thirds, that half bit into thirds, then I've got 6. Right, so 5/6 are green. And they want blue to green. So they want green on the right. So I'm going to do green from this end. That's 1, 2, 3, 4, 5. So I know that 5 is my green number. What have I got left over? Just the 1 blue. So that gives me ratio of blue to green being 1 to 5. So it doesn't have to be a bigger number to a smaller number. Sometimes it's a smaller one to a larger one. Now you can use a graph to help show what's going on in a ratio. An artist is making orange paint by mixing red paint and yellow paint in the ratio 8 to 11. So that means, in the way that we were talking about before, it's going to have 8 little pots of red you could think of with, and I'm going to use my green instead of the yellow here, with 11 yellow ones. 3, 4, 5, 6, 7, 8, 9, 10, 11. Now how can we show that on a graph? Well, if I've got 8 to 11, and that is red to yellow, that means when I've got 8 red, so 8 is 1, there's 1 square for each one here. When I've got 8 red, I've got 11 yellow. What if I were to keep the ratio the same, so that the colour that you made when you mix it together, but double the amount that I've got? I could do that just by adding another 8 red on, which would get me to 16, and adding another 11 getting me up to 22. So I was at 11 there, and then 22 yellow. Now if I make a little dot there, I'm going to do one more, and hopefully you may have spotted something that's happening here. If I did another 8 red, that would get me up to 24 on the red. And if I did another 11 on the yellow, that would get me from 22 up to 33. And I plot 24 against 33. I'm hoping now that you can see that they're lying on a straight line. And if I had none of one and none of the other, that would sort of work too. I mean, I'd have no paint at all, would I? So this graph should really use a pencil for this, but it's going to show up clearer for you if I use a pen. We can draw a nice straight line graph like that we can then use to find out. It says, and the artist decides to use 50 milliliters of yellow paint. Use the graph to work out how much red paint he should use. So we can do that by drawing across there and then down to make sure you stay on the same line to there, and that has come out at 37 milliliters. Got to keep the same units as they've put there, milliliters, otherwise you lose a mark. Alright, and that is as much as we're going to do for today. There's another question like that which we will start off with next time before doing some slightly trickier ones. I hope you found that interesting, and we will continue next time. Cheerio, folks.